Hello there, my dear friends in chemistry. At this point, you guys ought to have been introduced to some stuff on how to write what are called skeleton reactions, which basically just means how to write the reactants of a reaction and write the products of a reaction with their correct formulas. And we're just basically going to do a tutorial on just that. All right. So what are we trying to do? Well, first of all, we're trying to make sure we can identify what type of reaction it is so that we can then use those patterns from that type of reaction to predict what the products are, but not just what they are, writing the correct formulas of both the reactants and the products, right? So that's the kind of the gold standard for now. Now we're going to add some layers to this as we continue through this unit. But for now, this is what we want to be able to do. All right? What I need you guys to have in front of you for this tutorial, you guys should have a copy of ChemQuest number 28. We're going to focus in on that back page, that skill practice, right? Numbers 1 and 2, right? But in order to be able to do those, you need to have your periodic table. Hopefully, that is that annotated periodic table that you guys have been adding your own twist and information to throughout the year. All right. Now, moving forward, right? Like I said, we're going to focus on skill practice, last page, right? With numbers 1 and number 2. So for number 1, we're going to write a reaction from words. So in this case, we have sodium sulfate reacts with magnesium. So these are my reactants, right? My products, so this is a reactant, magnesium sulfate, product, and sodium is my product. All right. Now, we want to be able to write the reaction in its chemical form. All right. Now, what this entails me doing is applying what we've learned, right, about how to write formulas. So sodium, for example, when it reacts, it forms ions, sodium ions with +1, right? Sulfate, right? That should indicate to you that you guys need to look on your polyatomic ion sheet. Otherwise, if it was just sulfur, it'd be sulfide, sulfate. And if we look on your polyatomic ion sheet, we're going to see that that's SO4, and that has a -2 charge, right? And then we have magnesium by itself, so it is not an ion yet. It's just magnesium metal. So when I write this, right, these are my reactants. I'm going to do my crisscross method, put the 2 with the sodium, the 1 sulfate. So my formula for sodium sulfate is Na2SO4. Right? Remember that the subscript is already a part of those polyatomic ions states, right? But I don't need to write a 1 next to that sulfate. So I've got 2 sodiums for every 1 sulfate, and that is going to react with magnesium metal, right? And there's no subscript with magnesium because it's not part of a compound or anything. Okay? Now, we're going to now produce magnesium sulfate. So now magnesium is part of a compound, right? Which means it's going to be a magnesium ion with a +2 charge, and sulfate is still SO4 2-, right? And then sodium metal. So what I'm going to do, those are both 2s, so no, they cancel each other out. So no subscripts needed. It's just going to be MgSO4 plus sodium metal. Now again, some of you at some point in your careers, you might have learned about the need to balance equations, right? We are not worried about that yet. That is actually the next lesson that will be starting relatively soon. So if you've learned to balance, great. We're just not going to focus on the balancing side yet. We want to focus on writing the correct formulas for our reactants and products. All right, now next step, right, is the next part here, which is copper 1 carbonate. So this is a Cu+, right? That 1 there indicates that's a copper 1. And carbonate, the ATE again at the end tells me that's a polyatomic ion, CO3 2-, reacts with aluminum to form, so these are my reactants, and I'm going to form copper metal and aluminum carbonate. So I'm going to start with my reactant side again. So I got a +1 here, and that's a 2 minus there, excuse me. -2 there. So I'm going to go 1 carbonate, 2 coppers. So I'm going to write that as Cu2, CO3. Okay, it's going to react with aluminum metal. So that's just Al with no subscripts or charges attached to it. Now, my products are copper metal and aluminum carbonate. So copper metal is just a Cu with no subscripts or charges attached to it. Now, aluminum carbonate, so when aluminum forms an ion, it's an Al3 plus. Carbonate, still that CO3 2 minus. So those are not equal and opposite, so I'm going to have to put the 2 with the aluminum, Al2, and 3 carbonates. Now, because carbonate is a polyatomic ion, right, I put parentheses around it and then add that 3 to it. Okay, now, I'm not spending a ton of time on our rules for ionic compounds. I'm just reminding you of those rules. This is something you should have already known. It's why I spent forever saying you have to learn this, you have to learn this, you have to learn this to do chemistry the rest of the year. You need to be able to take the charges of the ions, right, and write the correct formulas. Now, at this point, if you were to write copper and aluminum carbonate but with an incorrect formula, the best I will give you is a 3, right, a B minus at this point. Now, down the road, I'm going to expect even better to get a 3, but for now, if you can at least do the patterns, right, even if you got your little subscripts wrong, for example, right, that's okay. Right, now, moving forward, right, the other thing we want to be able to do is, let's say I give you the reactants, and I even go so far as to give you the correct formulas for those reactants, right? You also want to be able to predict our products. Okay, so again, this is where recognizing our patterns is essential, right? So what I have here is like the last 2 reactions. I have what looks to me like a single replacement reaction, in which case I have a single element is going, if there were to be a reaction, is going to replace one of those 2 on our product side. Now, how do we decide which one it replaces, right? So again, it comes down to what is aluminum likely to combine with. Well, aluminum's a metal. Calcium's a metal. So typically in our reactions, we're not going to create a metal combined with another metal. Okay? We're going to combine a metal with a non-metal, which would be our nitrate. So my prediction would be that aluminum and calcium, right? So aluminum replaces, so a metal will replace another metal. A non-metal would replace another non-metal. Okay? That's the pattern that we have, right? And because we have a single element and a compound, that is our single replacement reaction. So I'm just going to swap aluminum and calcium. Now, so I have to combine aluminum and nitrate. Now, what I need to be able to do, right, is combine them with the correct formula. So I need to know their charges. So aluminum is, when it forms an ion, it's a +3. Nitrate is a -1, right? So that means 1 aluminum and 3 nitrates. So I'm going to put the parentheses around the nitrate and add a 3, right? And in this case, right, I would predict that calcium goes off then by itself. Okay? And the next one, okay, we have zinc, metal, and potassium phosphate. So again, we have a metal. We are likely to replace that other metal. Okay, so we're going to combine zinc phosphate and bring potassium metal off by itself. Now remember, the metals are by themselves. They don't get a subscript. Okay? Now, we still need to fix this formula so that it is correctly balanced in terms of charges. Zinc, as you guys should know, is a +2. Phosphate is a -3. So I'm going to do my crisscross applesauce, Zn3. I'm going to add another subscript to that phosphate, which means I need parentheses, and a 2. All right, that puts us right spot on 10 minutes. I hope this helped you guys move forward. Adios.